Here we go again. In this video, we're going to be solving absolute value equations. The first thing we're going to do is review the definition of absolute value equations, followed by solving a few examples of absolute value equations, and then finishing off with an example where we go through a three-step process of solving absolute value equations. Example 0 here, we're going over the definition of absolute values. We're given the absolute value x is equal to 4. So we're reminded about the definition of absolute values is the distance between 0 and a given point. In this case, we're asking what is the distance from 0 to 4? So there are two situations for this. If we start off at 0, then we move 4 units to the right. This would get us to positive 4. And when we do this exact same process, this time, however, we're moving to the left 4 units. This gives us the value of negative 4. So what is this telling us? This tells us that when solving any absolute value equations, we're going to have two possibilities, a positive possibility and a negative possibility. So we have two cases. As a result, in our final answer, we're going to have x is equal to 4, and we have x is equal to negative 4. So these are our two solutions. Here in example 1, it's a guided problem for us. We're asked to solve the absolute value of x minus 7 is equal to 4. However, both the positive and negative cases are set for us. So what does that mean? That means on the left side of each of the equation, we're just going to write exactly what's inside the absolute value and nothing else. So in case 1, we have x minus 7 is equal to our positive 4. And in our second case, we also have x minus 7. However, it is now equal to negative 4. Then we go through the regular process of solving our equation. So in the first case, we're going to add 7 to both sides, so that we're going to end up with x is equal to 11. And that would be one of our solutions. And our second solution would be solving the negative case. Since the left-hand side is essentially similar to what we had before, we're just going to add 7 to both sides. We, again, carry down our x. This is equal to negative 4 plus 7, which is going to end up being positive 3. And this will be our second solution. So when solving absolute values, we get to drop the absolute value bars as long as we set up our positive case and our negative case and continue solving equations. In example 2, we're going to continue to be solving absolute value problems. However, this time, before we can set up our two cases, our positive and negative case, we need to simplify everything inside the absolute value first. So inside the absolute value, we're going to have a negative 11. However, we're going to have to distribute the negative 2. So we get negative 2x plus 12. Then we continue carrying down the equal sign and the 5 on the other side. We continue simplifying inside our absolute values. So now we're going to combine negative 11 and positive 12. This will give us positive 1. And we bring down our negative 2x inside our absolute values. This is equal to positive 5. Now that we have done all of our simplification, we're going to now continue with our two cases. So we first start off with our positive case. We set it equal to 5. Then we have our negative case where we set everything to the left inside the absolute value equaling to negative 5. So in our positive case, we will have negative 2x plus 1 is equal to positive 5. And in our negative case, we're going to again have negative 2x plus 1. However, now it's just equal to negative 5. So now we're going to continue solving as if we were to do before. First thing we do, subtract 1 to both sides. So we get negative 2x is now equal to 4. Then divide both sides by negative 2. So in the end, our positive case would be x is equal to negative 2. Although this is our positive case, it's okay to have negative solutions. The case only matters at the beginning when we're setting things up. Now let's continue solving the negative side. So the very first step, we're going to subtract 1 to both sides. So we continue by bringing down negative 2x is equal to negative 6. Then we divide both sides by negative 2. Then we just have our x is equal to positive 3. Although this is the negative case, again, it's only for our setup. So it's perfectly fine that our answers is positive. And that's it for this example. In example 3, we're going to continue solving absolute values. However, this time we have to simplify or isolate the absolute values before we can solve for our positive and negative cases. So what we're going to do is take the absolute value statement. So we have the absolute value of 5 minus 1/2 x, and we're going to treat this as if it was its own variable statement. So essentially we're going to say this is equal to y. So we're going to have as follows. We have negative 2 y plus 17 is equal to 5. The reason we're doing this is because it is a lot easier to solve for a linear equation than it is an absolute value. So we begin isolating our y statement. So we can subtract 17 to both sides. So that now we have negative 2 y is equal to negative 12. Then we're going to continue doing inverse operations, divide both sides by negative 2, so that we now have y is equal to positive 6. So we have to remind ourselves that this y value is not what we're actually solving for. We did a substitution earlier stating that our y value is the absolute value. So now we're going to backward substitute back in the absolute value. So we have the absolute value of 5 minus 1/2 of x, and this is equal to 6 now. So using this method allows us to isolate the absolute values in an easier way. Now we can set up our positive and negative case. Now we have the positive version is going to be 5 minus 1/2 of x is equal to 6. Similarly, the negative version will be 5 minus 1/2 of x is equal to negative 6. So now we can solve for our x values. We're going to subtract both sides by 5, solving for our x value. So we have negative 1/2 of x is equal to positive 1. Then multiply by the negative reciprocal. So multiplying both sides by negative 2 over 1, allowing us to have now x is equal to negative 2. And we're going to quickly remind ourselves it's okay that our answer is a negative result even though it's the positive case. Because the positive case is only to set up the problem where we drop the absolute value bars. Likewise, now we're going to solve the negative case. So in the negative case, we're subtracting 5 to both sides again, so that we have negative 1/2 of x is equal to negative 11. Then we're going to also now multiply both sides by the negative reciprocal. So we're multiplying both sides by negative 2 over 1. So this gives us x is now equal to positive 22. And again, reminding ourselves this is okay. The negative case is only the setup, not the actual answer. And there you go. How do we solve for an absolute value problem with extra operations outside the absolute values, we just isolate the absolute values as if it was a giant variable of its own. And then we can set up the positive and negative case and solve for the required variable. And that's it. In example 4, we're going to follow a 3 easy step process of solving our absolute values. In our first step, we're going to isolate our absolute value statement. So we're going to treat x minus 7 inside the absolute value as if it was its own giant variable. So now we have as follows. We have 2 times the absolute value of x minus 7 is equal to negative 4. Then we want to use inverse operations by dividing 2 to both sides. So we have x minus 7 is going to be equal to negative 2. Now that we've isolated our absolute value, we want to move into step 2. In step 2, we're focusing on solving the positive and negative cases. So when we set up our equations on the left-hand side, will be just whatever's inside the absolute value. In this case, it'll be x minus 7. On the right side, for the positive case, we just copy exactly the same value on the right. So we're going to still have negative 2. When we set up the negative case, we're going to follow the same thing we did on the left-hand side. So that would just be x minus 7. We're going to set this equal to the negative of whatever is on the right-hand side. In this case, it's going to be the negative of negative 2. Now we can go through the process of solving for each of our cases. In the case 1, we're going to add 7 to both sides, so that now we have x is going to be equal to positive 5. Now we're going to solve for our negative case. We want to be sure to first simplify the right-hand side before we perform any inverse operations. So on the right-hand side, we just be left with positive 2. And on the left, we just carried down everything we haven't done yet. So now we can solve for our x. We're going to continue adding 7 to both sides so that our x is now equal to positive 9. Now that we have our two values of x, what we want to now do is to check both of these values of x to make sure they're the correct solutions for our original statement. So we're going to check x is equal to 5, and we're going to check when x is equal to 9. So in the checking process, we're going to copy down the exact same original equation. However, whenever there's a variable to substitute, in this case x, we're going to draw our parentheses. We're going to see when the left-hand side equals the right-hand side when x is equal to 5. So we're going to simplify the left-hand side. So we have 2 inside times the absolute value of negative 2. This gives us 2 times 2, which is 4. So what we're checking now is to see if 4 equals to negative 4. In this case, it does not. So this is a false statement. That tells us that x cannot equal to 5. Now we want to check to see what happens when x is equal to 9. So again, we're going to write our original equation. We're going to have parentheses where we're going to substitute in our variable x, and we're going to see if the left-hand side equals the right-hand side. So we're going to simplify the left-hand side. We now have 2 times the absolute value of positive 2. So we have 2 times 2 again, which is equal to 4. Then we're checking again, does 4 equals to negative 4? And this is also a false statement. So what does that tell us? That tells us that x does not equal to 9 as well. So in our conclusion, we can conclude that there are no real solutions because both of our x values do not work. We can also see a hint of this in our step 1. If we look at step 1 very carefully, we can see that on the left-hand side, this really says, hey, this is a positive value. And on the right-hand side, this is a negative value. So when does a positive number equal a negative number? It doesn't. So once we have isolated our absolute values, we can double check really quickly to see if this is a solution or not. So in this case, there's no real solution again. And that's it for our example 4. We are able to solve for absolute value equations in 3 easy steps. In our first step, we want to focus on simplifying and or isolating our absolute values. Once that is done, in our second step, we want to set up our positive case and our negative case in order to solve for our indicated variable. In our third and final step, we want to check our solutions to determine if they are true or false. These we solved by substituting our values back into the original equations. And huzzah, we're done.